In 1975, if you were looking for an FM stereo receiver and had $450, the equivalent of about $2,500 in February 2024, you could purchase this Sherwood S-8900a FM stereo receiver. Now this guy was rated at 60 watts a channel into 8 ohms, both channels driven, or into 4 ohms, 90 watts per channel, at not more than 0.3% THD from 20 hertz to 20 kilohertz. This particular unit was brought to me with the complaint that there was no sound whatsoever, and indeed once I plugged it in and hooked it up to my analyzer, I verified there was nothing coming out to the speakers, or dummy loads in this case. So what I'm going to do is do a little tour of the front and the back, and I'll pop the cover off and I'll show you what it looks like inside, and I'll describe what I did to repair this unit, and then of course there will be test data and I'll tell you what I thought after listening to it. Here is a close-up view of the Sherwood S-8900a. I think I may have called it the SG-8900a, but it is indeed, as you can tell, the S-8900a. Sorry if I confused anybody. Starting over on the left, you can see we have our FM tuning indicator, and it has a nice look to it. Obviously, it's powered on now. And what we have over here, a mode switch, so you can do the stereo mode or just the left or right side, or reverse the left and right, or put it in mono mode. You have your input selector over here, so you got auxiliary, FM, and phono, pretty basic. You have bass and treble controls, and we do have a balance control, and this is kind of where it needed to be pointed to give me a proper balance. We do have a tape dubbing jack out here if you didn't want to use the one in the back, and we do have a headphone jack here. Obviously, over here is our tuning knob, and this is our loudness or volume control. It actually doubles as the power off control as well. It's a little nit. I usually don't like the power on off switch on the volume control. I like them to be separate. Also, if it were pointed right about here, that would be the 29 dB position for it. Here is our 4-channel adapter push button, and if you had the 4-channel adapter for this unit, then you can flip it in that way. Tape monitor switch is here. We do have a high filter right here. This FM hush would be the FM muting switch, and the loudness switch is right here. Now, one thing that's a little bit odd is when you want the loudness off, you press it in. So normally it's the other way. When you want the loudness on, you push it in. But here, the loudness is off when it's in the pressed in position. And then you have your speaker selectors here. So you could be running all 4 speakers. You don't want 4 ohm speakers if you're running 4 of them. But these are your speaker push buttons here. I should point out that neither the balance nor the treble or bass controls have detents in them or a center detent in them. So it's kind of just pointing to where you think the center is. In this case, as I mentioned earlier, you needed to be over here close to the 2 to have the left and right channel balanced across the frequency band. This obviously is the rear of the Sherwood S-8900a. I should point out that this case, which encloses the top and the sides, it's one solid piece. It's a solid metal case that has venting on the top. Starting over here on the right, we have our FM 4-channel adapter that they were going to offer if FM 4-channel broadcast became a thing. You also had your 4-channel Dynaquad adapter, I think they called it, which could be plugged in here. Your phono input is here, as well as the ground for the phono, and then you had your auxiliary input here, and your tape monitor inputs were here and here. Now, I should point out that this phono sensitivity switch, the input of the phono when it's in the louder position is got a 47K ohm resistor at the input, and when you put it into the not the louder position where it's at now, it puts a resistor. They didn't specify what value resistor, but something to lower the input impedance to something other than 47K ohms. And here's your Dynaquad switch in and out, which you would switch in if you were having the Dynaquad adapter connected to here and here. Underneath this cover are the 4 output transistors, 2 of which were replaced that were on this side. You have a fuse here. You have both an unswitched AC outlet and a switched AC outlet. Our speaker connectors are all here, and you have the main ones here. So the main left and right are here, and then your satellite or remote are these guys here. These are somewhat knurled, so they're ones that you can just turn. You could do it with a screwdriver, or you can do it with your thumbs, because they do have knurling on them. You also have an output for a mono speaker, which kind of was for a center channel speaker, they said. And then you had your FM antenna connections here. Here's what the inside of the SG-8900A looks like with the cover removed. We have our tuner here. Here's our power transformer. We have 2 filter capacitors there. I believe they're 7,000 microfarad at 50 volts. This is our right channel driver board. This is our left channel driver board, and the repairs have already been made to this board, and you'll see what it looked like before. This is our speaker relay protect board. This board and this board and this board relate to the FM tuner, and this is a Phono preamp board. And then our output transistors are all here. There is a thermal cutout switch right there. And this kind of just shows what's going on the inside of this guy. And here is just another view of the inside of the unit. It kind of gives you a better idea of the output transistors and the thermal cutout here. And then this is the speaker protect relay board here. It's just a little bit different view. Once I had the cover removed, the very first thing that I noticed after about 3 seconds of looking around was this emitter resistor. And you can tell they kind of soldered it here and here, and then the center tap of the resistor went to this. It's an inductor, and then there's a couple watt resistor that goes through the inductor. They're in parallel, but anyway, that's how they connected it. And normally there's a resistor here and a resistor over here. They're 0.47 ohm 5 watt resistors. You'll see one on the right channel. This is the left channel. So that already was suspicious to me, and it turns out one of these legs, I believe this leg right here, was actually opened, and this leg right here actually measured, I think, 0.47 ohms. The other thing I noticed was somebody had been in before and replaced this capacitor. When a unit is brought to me that has a speaker protect relay or relays, and you power it on and you don't hear the relays come on, the first thing I suspect is shorted output transistors, 1 or more of them. Once I had the cover off and saw the emitter resistor tacked on there the way I showed it earlier, it made me suspicious of that channel. And the nice thing is that once you remove that little cover, which I showed you that covers the 4 output transistors, they're socketed, so they're easy to pull out. You don't have to unsolder anything. And tested them, and they were both shorted or very leaky. Also, one of the emitter resistors, and there's 2 of them, one's right here, these 0.47 ohm at 5 watt resistors. One of those was open, and so I replaced both of them with the proper resistors that should be on the board. And then whenever these guys are shorted, it's always a good idea to start checking at the driver transistors and working your way back. Now, what I discovered was the schematic is not indicative of what is on my board. Maybe they changed stuff around for different serial numbers is what I'm guessing happened. But particularly this guy right here, this is a single dual transistor, and this was not the way the board was built. So it kind of made it difficult because it changed the numbering a bit. However, once I started measuring these guys here and here and here, it turns out that this guy right here was shorted, and I had trouble finding a cross for this SPS. I mentioned earlier, I think, that these may have been a specifically designed for Sherwood or selected by Motorola for really matched pairs or something. And so they don't really cross to anything, and just kind of using some audio sense for replacements. I swapped them out with an NTE 32 for this guy and 31 for this guy. Even though this guy was still good, I just replaced them both. They were in those little sockets, so you could remove the little RTV around them and put in another one, put some RTV around it, and everything was okay. This guy is mounted on the same heatsink as the output transistors, and he tested good. And everything on the other channel tested good as well. So once I made those changes, and I did replace the electrolytic capacitors that weren't replaced, and powered it up slowly using a variac, monitoring the voltage actually right here for this channel going into this guy, and just making sure that the offset voltage was not really high. It can be up to like 200 millivolts for this particular receiver. So anyway, I did all that and everything worked fine after that. And there needed to be some adjustment of this bias right here as well. Here is the left channel driver board following its repairs. You can see that emitter resistor was replaced with two 0.47 ohm 5 watt resistors that went into their normal spot. The other thing that I replaced were these two capacitors here. To be honest, the ones I pulled out from 1974 tested basically fine, but in order to test them, it's just as easy to replace them at that point. But anyway, since this guy had been replaced, I just replaced these two. Also, there was a problem with one of these driver transistors, this one and this one. Now, apparently, they're a custom part number that Sherwood ordered from Motorola. At least that's what I found in doing some research trying to find a replacement. So there is no NT cross for them, or even if you have an old ECG catalog, sometimes stuff is in the ECG that's not in the new NT cross. But these guys here ended up being replaced by NT 31s and 32s. I don't know which was the 31 or 32, but one's an NPN and one's a PNP. But those work fine for here. And here's the bias adjustment. It honestly didn't have a lot of effect on things. And you can see the two output transistors that were bad that I replaced were these guys here. And they are the equivalent of NT 247 and 248, which are a Darlington pair output transistors. But that's what I used as replacements. And that's all that I found wrong on this board. So here's our standard THD SNR plot at, you guess it, 1 kilohertz, with the S-8900a putting out about 5 watts into 8 ohms. The left channel is a little bit more than 5 watts, and that's because I have adjusted both the balance and bass and treble controls to try to give me the flattest frequency response, which you will see what that is in just a moment. So the left channel is a little bit higher, but not that much higher. And I've adjusted the volume control, or loudness, as the Sherwood receiver has it labeled, and we're getting about 29 dB of gain. You can see our SNRs aren't too far off. They're, at least 65 dB. The THD's about 0.8% for the left versus 0.02% for the right. I should point out the left channel was the one that I had to replace the two emitter resistors, as well as the two output transistors, as well as the driver transistors for the output transistors. You can also see that the THD plus noise for the left channel is about 24, 25 dB worse than the right channel. And you can see that more clearly if I go ahead and turn off the left channel. You can see how low the harmonics are for the right channel compared to the left channel, and that's what's making that number not as good as the right channel. Here's our standard THD SNR plot at 1 kilohertz. In this case, we have 4 ohm loads attached to the Sherwood, and we're putting out pretty close to 5 watts. The volume or loudness control is still set for 29 dB of gain, and really the only difference between this and the 8 ohm load case is that our SNRs have gotten about 3 dB worse, but the THD is pretty much the same, and the THD plus noise, at least for the left channel, is about the same, and the right channel it got about 3 dB worse as well. This plot shows the frequency response from 20 hertz to 20 kilohertz, with the S-8900a putting out approximately 5 watts into 8 ohms. And you can kind of see that the low end of the band here is, maybe 2.3 dB worst case right here for the left channel. Also, the left channel does appear to have some kind of a high frequency noise going on with it. The right channel looks pretty good. Now, I did adjust both the balance and the bass and treble controls to try to give me the smoothest response. The frequency response is rated at plus or minus 1 dB, so it's kind of feeling that here at the very low part of the band. Once we get to 30 hertz, though, we're meeting the spec. And, this noise here is probably 0.2 of a dB worst case, so I'm not sure that would actually be heard. Here is the frequency response from 20 hertz to 20 kilohertz, with the Sherwood putting out about 5 watts into 4 ohm loads in this case. And if you compare it to the 8 ohm load case, there really is no difference between the two. It's still failing a little bit here. It should be plus or minus 1 dB. And once you get to 30 hertz, it meets that requirement. Here is a plot of the S-8900a's output impedance, and depending on which channel we look at, if we look at the left channel at a kilohertz, that would translate to a damping factor of 100. That's really good. And if we look at the right channel, this guy right here at 1 kilohertz translates to a damping of about 31. The specification was better than 30. Here is a plot showing the S-8900a's crosstalk, and this is with the active channel putting out about 5 watts into 8 ohms. There is a specification that at 1 kilohertz, the crosstalk should be better than 40 dB, and we are above 50 dB, so we're meeting the requirement. Also, the minimum crosstalk for the right to left down here would be about 37 dB, and for the left to right crosstalk, it's about 40 dB at the very worst case. This plot shows the THD versus frequency for a couple different output power levels, and that would be into 8 ohms. And the minus 4.1 would indicate about 40 watts into 8 ohms, and the minus 16.1 would be around 2.5 watts into 8 ohms. So as we saw earlier, the left channel at lower power levels had the greatest THD, and we kind of see that here and here. These are the two lowest power levels for the left channel, and we're right around a little bit above 1% or a little bit below 1%. But once we increase the power levels to maybe 5 watts or so, then the THD improves for the left channel. It's about 0.5% for the left channel, and then it starts getting better as we increase the power more, which is kind of what we saw for the left channel. And the right channel looks pretty good. The specification is that it should be better than about 0.3% THD. Right now, the S-8900a is putting out about 65 watts into 8 ohms, and that's at 1 kilohertz. There is a specification that at 1 kilohertz, it should be able to deliver 65 watts at not more than 0.3%. We're basically at 0.3% for the left channel, and the right channel is maybe 0.1%. So it's not looking too bad per its spec. SNRs are above 71 dB, we'll say, and the THD plus noise for the left channel is still at we'll call it minus 51. Now, the performance is better with it putting out more power. Sometimes that happens. And in case you're curious what the harmonics look like, here we have them. You can see that our third or odd harmonic is higher than the second or even harmonic, which usually is the case for solid-state amplifiers, but not always. Here is a plot of the multi-tone response of the S-8900a, the gain set for about 29 dB, and we're putting out about 6 watts into 8 ohms. There is no specification for it. It's just kind of for information purposes, but it's showing a distortion-free range of about 8 bits. So right now we're looking at the system noise of the S-2900a. In this case, our outputs are terminated into 8 ohm loads. Now I have the auxiliary input selected, and those inputs are terminated into basically shorts. So you're just looking at the system noise level with the volume or the loudness control in the Sherwood's case set for 29 dB of gain. Predominantly you can see noise here at 60 hertz, and then you have some other harmonics related to that power supply hum. Now I actually did check the hum with a scope, and I didn't really see really any ripple of significance on it. Now let me just compare the two channels. I'm going to get rid of the left channel, and you can see that the right channel peaks around minus 60 dBV down, and we'll put on the left channel. He's about 20 dB worse. There is a specification for the noise level with the auxiliary input selected, and that says it's minus 80 dB. So I'm going to go ahead and turn the loudness or the volume control such that it's all the way off or fully counterclockwise, and you can see that the noise level does improve. It's right around 75 dBV down or so. Here we have the effect of switching in the high filter or the loudness control on the S-8900a. This dark blue line going across the center here, that is with everything set flat. Well, it's not real flat here at the low part of the frequency band. It does have some roll off there. But if we look at what happens when we turn on the loudness control, we get, depending on the frequency, about 8 or 9 dB of boost here at the low part of the band. And it tapers off by 1 kilohertz. Now, when we flip in the high filter, we start getting a drop off at, it looks like about 2-3 kilohertz. It starts dropping off. And we also see at 20 kilohertz, we're down probably 8 or 9 dB. Right now we're looking at the THD SNR plot at 1 kilohertz with 4 ohm loads attached, and I've kind of amped up the input signal until I hit around 1% THD. What's interesting is the right channel looks worse than the left channel, and with 8 ohm loads it was just reversed. So it's kind of weird, but that's just the way this particular Sherwood is working. And we're getting, we'll call it 33 watts into 4 ohm loads would probably be the max that you would want to rate this guy at. SNR, they're better for the left channel, obviously, and the THD plus noise is much better for the left channel with the signal level increased until the distortion comes up. If I back that down just a little bit, things would improve quite a bit, but it's just kind of the way that this amp is working. Right now, I've got a 5 millivolt, 1 kilohertz signal applied to the phono input. There is only one phono input, and it's a moving magnet style. You can see our gains about 34 dB for this. THD looking really good. We'll call it 0.005%. SNRs, nothing to write home about 45 dB. And if I apply the RIAA weighting to it, things will improve a little bit on the SNR. So that's just kind of what it looks like. And now let's go look at its frequency response. Here is the frequency response of the Sherwood's moving magnet phono stage. It actually only has one phono input and it's moving magnet. The specification is plus or minus 1 dB across the 20 hertz to 20 kilohertz band. And I do have the RIAA weighting applied. Ideally, you would want a flat line going down the center here at 0, and we're not there. Actually, if you look at the minimum to the maximum, which is how you get your flatness, so we're down at about maybe minus 0.6 of a dB up to 2, so that would be about 2.6 dB. And if you do plus or minus 1.3 dB, we're not too far off. It just doesn't look real good, and it has a lot of boost here in the center part of the band, the low frequency band, and then at the high end it doesn't look so bad. And this is measured once again at the tape monitor output. As you saw from the test data, this particular S-8900a didn't quite meet up to its published specifications from about 49 years ago. Now, it wasn't too far off here and there, but at least in the 4 ohm loads, there was no way this guy was hitting 90 watts with less than 0.3% THD. And one channel was there at 65 watts, at least that's the 1 kilohertz rating, was 65 watts into 8 ohms, and the other channel was off a little bit, so it wasn't so bad. The frequency response on the low end of the band kind of lacked a little bit, but you can boost that up with the loudness control. And when I talk about my listening test in just a minute, I did have the loudness control on, and the bass sounded just fine at that point. So overall, I thought that its performance on the bench was not stellar, but it did okay. And you know, it's 49 years old, and other than the few capacitors I replaced, as far as I can tell, it's basically all original. Now, as far as the listening test, I connected it to my Wilson Watt 3 Puppy 2 loudspeakers, and the first thing I do is terminate the auxiliary inputs into shorts and listen for hum. And I really didn't hear anything unusual. Now, when I listened to the hum, it's set for about 29 dB a gain, and I did not hear really that much hum. It was about normal, what I hear for amplifiers. Just a little bit. You walk away, you know, 2 feet, and you wouldn't really hear it. So overall, that part was nice. There was no pops and clicks. And then when I listened to it through the variety of music, I thought it did just a fine job. It just sounded quite good. I liked having that loudness control on to boost up the bass, and I thought it delivered as much as I needed. I thought the power output was just fine for the levels that I hit, and I was hitting close to 90 dB. I think I got up to maybe 87 dB SPLs, and it did just fine. Now, I should mention that this guy does run hot. The heat sinks for the transistors or the whole back plate, and that does get a bit warm, I think, for my test, unless it's just idling at, you know, maybe a watt or two of output power. But once you start getting about 5 watts, it does get warm, not where you're going to burn yourself by no means, but it does run warmer than other amps that I have tested of this kind of setup. But it does have a thermal cutout, so if the heat sink or the back plate got too hot, it would kill the power to the amplifier. So that's a good safety precaution. It does have a speaker protect relay, which was engaged, which is why I didn't have any sound to begin with. And that monitors both the DC offset voltage coming out, as well as if too much current is being drawn, it will click the speaker protect relay. Hopefully, at least it worked to start with. So, you know, that's kind of it. Now, as far as the aesthetics, I think this has a nice look. It has that kind of mid-70s look. It just looks good, especially in low light. Probably you can't see here, but in lower light, the backlit display and the tuner dial, it's just a nice blend. Speaking of the tuner, I did test it, and it tuned just fine. It works really well. And they put a lot of design into their FM tuner section, and that kind of showed when I was listening to it. So, you know, if you're looking for a nice vintage amplifier, because it's Sherwood, it's probably not going to break the bank. And once again, with old stuff, you should always try to listen to it if you're not able to fix it yourself, or maybe have somebody who's more versed in repairs check it out for you before you purchase it. But my guess is you could probably pick one of these up at a decent price if it looks good. You know, it's a nice piece of vintage gear, FM only, of course. Also, I would point out it does have all the original lamps. Now, they may have been replaced at one point, but they're all incandescent in here. And it just is a decent piece of vintage gear, in my opinion. So if you liked the video, please click the thumbs up. If you have comments, please write them in the description area, and I will be sure to reply back to them. And if you have not subscribed to the channel, please do so. That helps the channel grow. And until next time, have a great day or night.